guys, in today's video we're going to look at the amphoteric nature of water, the equilibrium constant, the ionic product of water, how to calculate the pH of strong bases, and finally an exam style question.
Well, water is rather special in that it's an amphoteric substance. It can act as both an acid or a base. It can act as an acid in certain circumstances by donating a proton, or as a base by accepting a proton to form this hydronium ion over here. Now, water actually exists as an equilibrium between the H2O, the water molecule, undissociated, and an H plus and OH minus ions. Now, in reality, the equilibrium lies well over to the left. Very little water exists as in its dissociated form at any given time. So we can actually write an expression for this dissociation, which we'd write as this, where Kc is our equilibrium constant. Now, the concentration of water, or H2O, is actually considered constant. So what we get is we get Kc multiplied by the concentration of H2O, and we get a new constant, which we call Kw, and this is our ionic product of water. So let's have a look at that now. Here we have our equation for Kw, which is the concentration of hydrogen ions multiplied by the concentration of hydroxide ions, and this is our ionic product of water. The units for this are always moles squared decimeter to the power of -6, because you can see what we're doing. We're multiplying together two concentrations given in moles per decimeter cubed. Now, pure water produces the same number of hydrogen and hydroxide ions, and the pH of water at 25 degrees Celsius is 7. What that means is that the concentration of hydrogen ions in our water is 10 to the -7 moles per decimeter cubed. And as we have the same concentration of hydrogen ions and hydroxide ions, the concentration of hydroxide ions will be exactly the same. So to work out a number for Kw is fairly easy then. We have 10 to the -7 moles per decimeter cubed of both hydrogen and hydroxide ions, which means Kw, or ionic product of water, is equal to 10 to the -14. That's an incredibly important number, and one you need to remember because we'll be using it in our equations later on. So let's have a look at some of those equations right now. We can use the equation for the ionic product of water to work out the pH of strong bases.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, click the button. Join me today and together let's make A-level chemistry a walk in the park.